Hello, welcome back for lesson 10.3. The main point is that we're working on two independent populations proportions. So we're working with two samples and we're comparing them, and they're all about qualitative data. And again, let's talk about qualitative data that is in a question that you would have to answer as a yes, no, and it would have to be tallied and put into some kind of a percentage form. We call that percentage or proportion. Okay, so that's what you're going to be looking for. So you're also going to be looking in your notes packet on page 304. So write that down, 304. It's testing the difference between two proportions, independent samples. Okay, we're not going to do this by hand. We're going to write it out, the 6 steps. Remember, I'm expecting all 6 steps on your homework and on the final exam, but we're going to be using the computer program in Desmos. But this first example here is going to be using some more printouts, just so you can see what printouts would look like if you're ever using them in another course, in business or psychology or sociology, something like that, economics. So it says the General Social Survey tracks trends in American society through annual surveys. Married respondents were asked to characterize their feelings about being married. A researcher wants to test whether the proportion of males who report being very happily married is larger than the proportion of females. Sample 1 was married females, sample 2 was married males. So down here in the printout, I'm just going to write females and males. Okay. And it says, a researcher wants to know whether the proportion of males who report being very happily married is larger than females. So they're saying males is larger than females. Or we can write it as females is less than males. Remember that. So when you look on the printout, it may be one or the other. Okay, the hypothesis test outputs for 2 computer programs are below. Use these results to answer the questions. So let's just look at the 2 outputs. We have StatCrunch and Minitab, similar to what we had in 10.1 as well. And notice they just give things in a little bit different format. So in StatCrunch, they show us the hypothesis test, and it looks like the difference is less than 0, but it's P1 minus P2. So that would be female minus male is less than 0. And if you look down on letter A question, it's asking us what that means. Explain why the researcher wants to test this hypothesis and why the computer outputs have this. So the difference less than 0 is the same as P1 is less than P2. Because if you add P2 to both sides, you'll get P1 is less than P2. And remember, that is females less than males, which is the same as males is greater than females, because that's what they asked. They asked if the proportion of males who report being very happily married is larger than that of females. Okay. This is how many married females were surveyed. So we're looking for counts and totals. So totals is our N in the sample, and counts are the X's. And total 1 would be the females. So there were 423 married females. And it says how many married females reported being very happy. So that's up here under our count. 257 of them reported being very happy. Now, letter D says, find the proportion 1 or the proportion of females. So that is the 257 divided by 423. And we're going to find that and put that here under sample P, sample. So we're going to go share our screen. And we're going to go to Desmos. And I'm going to type in 257 divided by 423. So the proportion for women is 0.6076. And then the proportion for men is 242 divided by 366. So theirs is 0.6612. So it looks higher, but we have to decide using hypothesis test if the males are significantly higher. Okay, so let's go back to our paper. So there's my two proportions. Okay, how many married people were surveyed total? So our total people surveyed were 23 plus the 366 is 789 total. Compute the sample proportion difference. Okay, so that would be P1 hat minus P hat 2 equals 0.6076, subtracting 0.6612 equals 0.0 536. 0.0536. State the test statistic and circle it in each output. So the test statistic is the Z statistic because when we're talking about proportions, we're using a Z critical value. So a Z test statistic, very similar. Remember Minitab from 10.1, they tend to round more than in StatCrunch. And then our p-value, we're going to box it in. So there is our p-value for each. Okay. So our test statistic is a negative 1.56, and our p-value is 0.07. Just use a computer output to perform step 4. So that step 4 is all about the picture. And it was a less than, so we're testing over here. And this is our p-value. The probability that we're further than 1.56 standard deviations away. So not extremely outrageous, right? Because if we go back to our chapter 2 rule, our chapter 2 rule was 2 standard deviations below or 2 standard deviations above. So Jay says, if the researchers set alpha at 0.05, would the results be statistically significant? Remember, statistically significant means, are we going to reject H0? So we always compare our p-value compared to alpha, and alpha is 0.05, and our p-value is 0.06. Our p-value is bigger, so we do not reject H0, which means it is not statistically significant. Okay. If the researcher set alpha at 0.05, what conclusion would be reached? So, because we do not reject H0, there is not, remember we do not and there is not sufficient evidence to say that the proportion of happily married males is higher than females. We do not reject, there is not sufficient evidence. If the decision made above is incorrect, what type of error would this be? So our decision up above was do not reject H0. So the only error that could be made is when you do not reject H0 would be a type 2 error. because that is do not reject H0 when H0 is false. Not reject H0 when H0 false. So that means we said there's not enough evidence to say married males are happier than females, but it could be a type 2 error that really they are happier than married females. Okay, we're going to look at, I think, 3 or 4 more examples. And we are going to use the computer program in Desmos, and I'll show you where to find that in the modules. Let's look at our situations. As researchers from the Pew Forum on Religion and Public Life interviewed 2 random samples of people. Both samples had 1,500 people. In 2002, 645 people expressed support from stem cell research. In 2009, 870 expressed support. Let group 1 be the 2002. So group 1 is the 2002. Group 2 is the 2009. Okay. So 2002, the p-hat would be the 645 out of the 1,500. And in 2009, it was 870 out of the 1,500. And this is people that express support for stem cell research. Okay. So it looks like, because they're both out of 1,500 and the X went up, so it looks like support is increased, but let's see what they want us to test. Perform a hypothesis test that the proportion of people who support stem cell research has changed. So the word change tells us that we're going to do a not equal to, a two-tailed test. Okay. So the hypothesis is going to be H0 and H1 or HA. And it is the proportion 1 is equal to proportion 2. And then our H1 is proportion 1 is not equal to proportion 2 because it said it has changed. Our alpha is the 1% level, so that's 0.01. And we're going to use that in our decision down here because in our decision, we're always comparing the p-value to the alpha. So that's where, so that 1% is only used as our alpha. It doesn't have anything to do with our sample proportions or our test statistic. Okay, so our test statistic, remember, is a 2 proportions test statistic. So it's a Z0. We're not going to have to calculate this. I don't want you to write out the formula, but we're going to go to the modules in Canvas to find the little program for Desmos. And I suggest that you save it so you don't have to keep going back to Canvas. So let's go find that. So first of all, I'm going to do my calculations on the proportions of people that support. So 2002 is 0.43 and 2009 is 0.58. So it does look like they've increased, but we have to check for the statistical significance of the increase. So 0.43 and 0.58. Okay, now if you go to the course modules, if you go to the module that I created that has Desmos links, near the bottom, the second from the bottom says 2 proportions, confidence intervals and hypothesis test, chapter 10. If you click on that and open that Desmos link, it tells us to enter sample data. And notice they're in folders. So we've got group 1 and group 2. So group 1 is going to be, in this case, our 2002 data. So our N was 1,500 and our X was 645. And if you're wondering where the p-hat is, if we go all the way down to the bottom, I'm fairly sure that's where they give us our p-hat. So p-hat 1 is 0.43. Now we haven't calculated the other one yet. So in group 2, again, we have 1,500 in the sample, and we had 870 that said they were supporting stem cell research. So we can go back down the bottom and validate that p hat as well. So it's set up just a little bit different than our 10.1. Okay. So now, because we had a two test, we're going to go here and click on the two test. And we're going to scroll down. So our, right here, our p-value is very small. Very, very, very small. So we're going to write that our test statistic. Oh, first of all, our test statistic right here is a negative 8.216, which is very, very crazy far from our sample, from our center. Okay, that there would be no difference. So that's why our p-value is so small. So yes, our p-value is 2.22, but that's times 10 to the negative 16. So don't forget about the scientific notation here, which tells us that it's very, very, very small. Okay, so if we go back to our paper. And we are doing a two-tailed, so we're going to shade both sides here, and we're going to point that our p-value is kind of split between the two. And yes, our p-value is much smaller than 0.01, so we do reject H0. So because we do reject H0, there is sufficient evidence to support the claim that the proportion of people who support stem cell research has changed. Remember, we can only say that it's changed. We can't say it's went up. We can't say what the new proportion is. We can only say that it's changed between the 2 years. So let's check out the next example. So this is example 3. I got my numbers off here on examples. So the next example is called love at first sight. Which is funny because their first example was people that were happily married. I must be a savvy person. So it says in a random sample of 80 college graduates, 44 said they would not marry a person based on only on love at first sight criteria. For a random sample of 120 high school graduates, 42 said they would not marry a person based only on love at first sight criteria. At alpha 0.02, would you say that there's a difference in the two proportions? So we're comparing college graduates to high school. So our step 1 is going to be our H1 and our HA, or H0 and our HA. So I'm going to say P for C for college graduates is equal to P for high school graduates for H. And they're saying, is there a difference? So that's going to be a not equal to. So that means on our picture, we're going to get our picture started and it's going to be a two-sided because our picture matches what's in our hypothesis statement. Our alpha, they said, was at 0.02. Our test statistic is going to be a Z0 from the program, but let's just write out what we have. So we have sample 1 has 80 from our sample of the college students, and X of them, so X of C had 44. And then the sample of the high school students, there was 120. And of the high school students, 42 of them said. Okay, so let's go ahead and put these numbers in to our program. So in group 1, we had 80 and 44. And then group 2, we had 120 and 42 of them. So let's go down and just write down our proportions. So our P hat 1, our P hat for the college students is 0.55, and our P hat for the high school students is 0.35. And so we're going to go up, and because it's a two-tailed, we're clicking on the one that says not equal to right here. So click on that. And then there is our P value is 0.0051, so pretty small. And let's go back down to the bottom. It gives us our Z. So our Z score is 2.7988. So it's pretty far away from the center. So I'm guessing we're going to reject. So let's go back to our paper. There is our test statistic Z, and our p-value down here in step 5 compared to our alpha of 0.02. So again, our p-value is split between these two. Our p-value is quite small, so we do reject H0. So there is sufficient evidence to support the claim that there is a difference between the two proportions. So that is the Lovett first set. So let's look at example 4. Example 4 is victims of violence. A random survey of 80 women who were victims of violence found that 24 were attacked by relatives. A random survey of 50 men found that 6 were attacked by relatives. At alpha point 10, can it be shown that the percentage of women who were attacked by relatives is greater than the percentage of men? Use the p-value method. So H0 and HA, I'm going to call them proportion of females, or we're going to do women. Let's do W for women equal to the proportion of men. And then is greater. So they're asking if the proportion of women is greater than men who are attacked by relatives. So women greater than men. Okay, so we have N for the women. There were 80 of them, and X for the women were 24. And then N for the men were 50, and X for the men were 6. So my P hat for the women, we've got to find that, and then my P hat for the men. Okay, our alpha we're going to use is 0.10, and then we're going to find our test statistic. And because it's a greater than, we're going to go ahead and get our picture started down here. And then we're going to get prepared that we're going to compare our p-value to our alpha, which is 0.10. We're going to go to our Desmos program that we found in the modules that you have saved in your own Desmos, so it's ready to go. We're going to enter these values to get our sample proportions. So we're going to go back to the top. And we had 80 women and 24 of them. And then we had 50 men and 6 of them. Remember that you're putting in the N first and then the X. Let's go to the bottom. So the percentage of women was 0.30 and the percentage of men was 0.112. And our test statistic is 2.3698 right here. It's our test statistic. And that's definitely further than 2 standard deviations above the mean of 0. So I'm guessing we're going to reject. So let's go ahead and click on our greater than, because that's what we were looking at. And it looks like our p-value is pretty small again, 0.0089. 0.0089 when we round it appropriately. So let's go ahead and go back to our paper and finish that up. So our p-value is definitely smaller than our alpha, so we do reject H0. So there is sufficient evidence to support the claim that percentage of women is higher than men. So the percentage of women that were attacked by relatives is higher than the percentage of men that are attacked by relatives. It's unfortunate either way, being attacked by relatives. So I'm going to go ahead and go to the next example. Okay, example 5 says animal bites of postal workers. In Cleveland, a random sample of 73 male carriers showed that 10 had been bitten by an animal during 1 week. In Philadelphia, a random sample of 80 male carriers 16 had received animal bites. Is there a significant difference in the proportions? Use alpha at 0.05. It says find the 95% confidence interval for the difference of the 2 proportions. So I have it set up for hypothesis test, but we're going to use a confidence interval to do that. So let's just write our H0 and HA. Our H0 is going to be the proportion of Cleveland equal to the proportion of Philadelphia, P. And then they're saying, is there a significant difference in the proportion? So that would be a not equal to. So our N for Cleveland is 73, and the X for Cleveland is 10. So we need to have the P hat for Cleveland. And then our N for Philadelphia is 80, and the X for Philadelphia was 16. So we need to know the P hat for Philadelphia. The alpha we're going to use is alpha is 0.05, 95% confidence interval. So to find a confidence interval with 2 proportions, you're going to go to your formula packet, and on page 303 are the formula, the formulas for the confidence intervals for the 3 situations of 2 samples. We're talking about 2 sample proportion. So we're going to be using this formula here. So that formula, I'm going to write it on my paper, is P hat of the Cleveland minus the P hat of the Philadelphia, plus or minus our Z of alpha divided by 2. So that's going to be the Z of 0.025, because we're going to take 0.05 and divide it by 2. And then we're going to multiply that by the square root of P hat Cleveland times 1 minus P hat Cleveland over the sample size for Cleveland plus the P hat for Philadelphia times 1 minus the p hat for Philadelphia over the sample size for Philadelphia. Now, these pieces will come into that program, but it doesn't give you the actual confidence interval itself. So a z of 0.025, we can find either using our inverse norm, or that's a common one. So we can go to page 299 in our formula packet and we'll go to the bottom and look at 0.025 and find out that that's 1.96. So this is going to be plus or minus 1.96. And then we're going to find the difference here. And then this square root piece is our standard deviation that's going to give us in the program. So let's go ahead back to our computer program here. So we're going to go up to the top and put in our information. So we had 73 in the sample, 10 from Cleveland. And then we had 80 in the sample and 16 from Philadelphia. So we scroll all the way to the bottom, we'll find the two p hats. So Cleveland is we're going to round that to 0.14, and then Philadelphia is 0.2. So our difference is going to be 0.14 minus 0.2, which is 0.06. Okay, I'm going to just calculate that here, 0.14 minus 0.2. So you can see that it's a negative 0.06. So make sure that you note that it's a negative 0.06. Okay, then if you scroll up, you'll see that square root piece right here where my mouse is. That's S. So 0.0608. 0.0608. And we're going to then put this in down here. So we're going to say a negative 0.06. That's our difference. And we're going to subtract our z, which is 1.96, times, and we could actually just type in S up here because they've already labeled it as S. So we could put S right there. And it's going to tell us that our lower limit of the confidence is a negative 0.1791. And then we can, and notice if I would have put in our rounded value of 0.0608, it would be pretty close to the same. Okay, but we're going to use S because they've already calculated that for us. And we're going to change this to a plus, and we get our upper is 0.0591. Okay, so let's go back to our paper now that we have the confidence interval. So we're 95% confident that the true difference between Cleveland and Philadelphia is somewhere between this negative 18% and a positive 6% difference. Okay, so if we're testing to see if there's just any difference at all, we're testing basically to see if there is a difference, then 0 wouldn't not be in the confidence interval. So let's write that out. If there is a difference, then 0 would not be contained within the interval. But 0 is in the interval, is because it's negative to positive. 0 is in the interval. So we cannot say there is sufficient evidence to say there is a difference. Okay, because 0 is within there, then we're saying that there is really no difference between them. If 0 was not in there, we could say there was a significantly enough difference to say there is. So that's how we can use a confidence interval. This is a 95% confidence interval. The last example, example 6. It says, the percentage of males 18 years and older who have never married is 30.4. For females, the percentage is 23.6. Looking at the records in a particularly populous county, a random sample of 250 men showed that 78 had never married and 58 of 200 women had never married. At the 0.0 level of significance, is the proportion of men greater than the proportion of women? So even though they give us some historical information, we don't really need that. So we can cross that out. Okay, so let's look at the X for men. There were 250, no, the N for men, sorry, the sample size for men was 250. The X for men was 78. And we're going to find the P hat for men here in a minute. And then the sample size for women is 200. And the X for women is 58. And then we'll find the P hat for women momentarily. So our H0 and HA. So we're saying the proportion of men is equal to the proportion of women. Talking a lot about being married today, aren't we? And then the proportion of men, and we're asking if the men are greater than the women. So greater than the women. Proportion of men that never married is greater than the proportion of women that never married. Okay. Our alpha, they said to test at 0.05. So we can fill in a few things. It's a greater than, so it's going to be a right-tailed test. And we're going to be comparing our p-value to an alpha of 0.05. So let's head to our computer program one more time. Scroll all the way up. So the men there were 250 and 78 of them said they were never married. And of the women, 58 of them said they were never married. And so we're going to go scroll all the way down. We're going to get those P hats. And so the proportion of men is 0.312 and the proportion of women is 0.29. They look like they're pretty close together, but let's go up and our Z-score right here is 0.505. So it's not very big. So our test statistic Z0 is 0.505. So let's scroll up. We're looking for a greater than test right here. And our p-value is pretty small. Or I mean, pretty big, 0.3068. For a p-value, that's pretty big. Let's go back to our paper to wrap it up. So there's our test statistic, only a half a standard deviation above 0. And our p-value is pretty large. It's much larger than our alpha. So we do not reject H0. So we do not, so there is not sufficient evidence to support the claim that the proportion of unmarried men is more than unmarried women. There's not enough evidence to say that the men that have never married is any more than the women who have never married. And that wraps up lesson 10.3 on two proportions. So that's what we just worked on, comparing two independent population proportions. Catch me back for another video.